American V8s and European turbocharged engines don't just sound different, they don't just feel different, they are built on completely different engineering philosophies. And once you understand why, you'll never look at engines the same way again. In America, engines were never just about efficiency. They were about presence, big displacement, deep sound, effortless power, and mechanical honesty. American manufacturers like Ford, Chevrolet, and Dodge built engines that didn't need to prove anything through complexity, because their philosophy was simple. If you want more power, make the engine bigger. That's why engines like the Chevrolet LS series and the Ford Coyote V8 became icons. These engines focused on naturally aspirated performance, strong low-end torque, and simple, durable construction. Instead of relying on highly complex systems, they delivered power through displacement, robust internals, and proven mechanical design. In many cases, American V8s used pushrod valve trains, which were more compact and mechanically simpler than the overhead cam layouts commonly found in European engines. That simplicity wasn't a weakness. It was the point. It made engines easier to package, easier to maintain, and easier to repair. And that mattered in a country built on long highways, huge distances, and a culture that valued reliability and straight-line performance. America had relatively cheap fuel, fewer concerns about squeezing every mile out of a gallon, and a driving culture built around effortless acceleration. People wanted engines that produced strong torque right off idle. Engines that felt powerful without needing to be pushed hard. Engines that mechanics across the country could service with basic tools. That's why American engines earned a reputation for durability, longevity, and user-friendly maintenance. They weren't always the most fuel-efficient or the most technologically advanced, but they were honest, dependable, and full of character. Then you look at Europe and the philosophy changes completely. European manufacturers faced a very different reality. Fuel was expensive. Emissions regulations were stricter. Roads were narrower. Driving conditions were more varied. And performance was often expected without the luxury of huge displacement. So instead of asking how to make engines bigger, European engineers asked how to get more power from less engine. That one question shaped decades of engine development. European manufacturers like BMW, Mercedes-Benz, Audi, and Volkswagen focused on extracting maximum performance from smaller displacements using advanced technology. Turbocharging became the core of that philosophy. Instead of relying on large naturally aspirated V8s, Europe embraced forced induction to make 4-cylinder and 6-cylinder engines perform like much larger power plants. A smaller turbocharged engine could produce impressive horsepower while still delivering better fuel economy and lower emissions. That balance of efficiency and performance became the defining trait of European engines. And to make it happen, European engineers leaned heavily into complexity. Overhead camshaft layouts, variable valve timing, direct injection, advanced engine management systems, variable geometry turbochargers, and highly refined combustion strategies became standard tools in the European approach. These engines were not just designed to make power. They were designed to make smart power. Power that could meet strict environmental rules, deliver strong performance, and still remain efficient in everyday use. One of the biggest visible differences between these two worlds is displacement. American engines traditionally relied on size. European engines relied on sophistication. A classic American V8 often displaced anywhere from 5.0 to 7.0 liters, and in some performance applications even more. The philosophy was straightforward. More displacement means more air, more fuel, and more power. These larger engines produced substantial torque at low RPM, giving American cars and trucks that effortless, muscular-feeling drivers loved. They didn't need to rev high to feel strong. They delivered their punch early, and that made them ideal for towing, highway cruising, and stoplight acceleration. European engines, on the other hand, were often much smaller, commonly ranging from 1.0 to 3.0 liters. But with turbocharging and advanced fuel systems, these smaller engines could produce outputs that once required a large V8. A modern 2.0-liter turbocharged European engine can generate serious horsepower while offering better fuel economy and lower emissions than a traditional large displacement engine. It's a different way of thinking. One says power comes from size. The other says power comes from efficiency, pressure, and control. Fuel delivery systems also reveal the philosophical divide. American engines traditionally favored port fuel injection. In this system, fuel is sprayed into the intake ports before entering the combustion chamber. It's a simpler and more proven setup that offers smooth operation, reliable fuel mixing, and fewer long-term issues with carbon buildup on the intake valves. Port injection worked beautifully with naturally aspirated engines and fit perfectly with the American preference for simplicity and long-term durability. European manufacturers moved earlier toward direct injection, where fuel is sprayed directly into the combustion chamber under very high pressure. This gives engineers more precise control over combustion, improves fuel economy, supports higher compression, and works especially well with turbocharged applications. But it also adds complexity. Direct injection systems can suffer from carbon buildup, high-pressure fuel pump issues, and more expensive diagnostic challenges. European manufacturers accepted those trade-offs because the benefits in efficiency and power were worth it. Over time, American manufacturers began adopting direct injection too, often pairing it with port injection and dual injection systems to combine efficiency with long-term cleanliness and reliability. That modern blend shows how much the two philosophies have started learning from each other. Turbocharging itself tells an even deeper story. Europe embraced turbocharging seriously in the 1970s and 1980s, driven by fuel crises, emissions regulations, and the need to get strong performance from smaller engines. European companies poured years of engineering into refining turbo systems, improving boost response, integrating sophisticated controls, and building engines around forced induction from the ground up. For Europe, turbocharging wasn't just a performance trick. It was a necessity. In America, turbocharging arrived with more hesitation. American manufacturers and buyers had less reason to abandon large naturally aspirated engines because fuel was relatively cheap and big engines already delivered the power people wanted. Early American turbo efforts were often inconsistent, and reliability problems created skepticism around turbocharging. For many Americans, a turbo felt like unnecessary complication when a V8 could do the job more simply. But modern emissions pressure and fuel economy demands eventually changed the game. Engines like Ford's EcoBoost proved that turbocharged V6 and four-cylinder engines could deliver strong torque, competitive power, and better efficiency while still feeling familiar to American drivers. Even then, American turbocharged engines were usually tuned to mimic naturally aspirated characteristics, focusing on low-end torque and smooth delivery rather than peaky, high-strung behavior. European turbo engines often leaned more aggressively into high specific output and broad power bands, rewarding drivers who enjoyed using the full RPM range. Regulations also played a huge role in shaping these engine cultures. In America, emissions rules and fuel economy standards developed through somewhat separate systems. Manufacturers could often keep larger displacement engines alive by using catalytic converters, refined engine calibration, and improved exhaust aftertreatment. That allowed them to preserve the power characteristics American buyers expected while still meeting regulatory requirements. In Europe, emissions and CO2 targets pushed manufacturers towards smaller, more efficient engines much earlier and much harder. European regulations effectively forced innovation in combustion efficiency, turbocharging, diesel technology, and lightweight engine design. That's why so many advanced fuel-saving and emission-reducing technologies appeared first in European cars. Start-stop systems, small displacement turbo engines, highly refined diesels, and complex hybrid integration all became part of the European toolkit earlier than they did in the American mainstream. These different regulatory paths didn't just shape what engines were built. They shaped what drivers came to expect from an engine. Maintenance is another place where the two philosophies become impossible to ignore. Traditional American engines were designed with serviceability in mind. Components were often easier to access, maintenance procedures were more straightforward, and independent mechanics could work on them without factory-level tools or specialized training. Oil changes, spark plugs, ignition components, and basic repairs were generally less intimidating and less expensive. This helped create a culture where owners expected their vehicles to be maintainable over the long term at reasonable cost. European engines often accepted greater complexity in exchange for better performance and efficiency. That meant tighter packaging, more electronic integration, more sensors, more specialized parts, and more advanced service procedures. Individual maintenance events could be less frequent in some cases, but they were often more expensive and more dependent on specialized diagnostic tools and trained technicians. Variable valve timing systems, turbocharger plumbing, high-pressure injection systems, complex cooling circuits, and advanced engine management all added capability, but they also added cost and complexity. In simple terms, American engines often asked less from the owner. European engines often offered more but expected more in return. The actual driving experience reflects all of this. American engines traditionally emphasize torque, especially at low RPM. You feel that immediately when you press the throttle. There's a heavy, effortless shove that doesn't require drama. The power is available early, and it suits highway cruising, towing, and relaxed confidence. That's why American V8s feel so satisfying even when you're not pushing hard. They make everyday driving feel easy and strong. European engines often focus more on how power builds. Even when they produce excellent torque down low, they're usually engineered to feel lively across a broader RPM range. They encourage more active driving. They reward throttle inputs, gear changes, and higher revs. The engine feels like something you interact with rather than just something that pushes you forward. This matches the European performance culture, where tighter roads, higher-speed autobahn sections, and more enthusiastic driving styles shape the tuning of engines and transmissions. One philosophy creates effortless force. The other creates intelligent performance. Neither is wrong. They are simply answers to different questions. And now, in the modern era, the line between them is starting to blur. American manufacturers have adopted many of the technologies Europe helped normalize: direct injection, turbocharging, downsizing, hybrid assistance, and sophisticated engine management. At the same time, European manufacturers have put more effort into improving reliability, simplifying modular engine design, and making service procedures more practical than in the past. Global emissions rules, shared markets, and customer demand for both performance and efficiency have pushed both sides toward a kind of middle ground. Today, many American engines offer European-style efficiency without fully giving up their focus on durability and torque. And many European engines are better engineered for long-term ownership and real-world drivability than ever before. Consumers benefit from this convergence because modern engines increasingly combine the strengths of both traditions. But even with all that convergence, the core identities still remain. American engines are still rooted in the idea that power should feel big, immediate, and dependable. European engines are still rooted in the idea that power should be extracted intelligently, efficiently, and precisely. American V8s represent confidence through displacement. European turbocharged engines represent innovation through pressure and control. One is muscle. The other is precision. One wins your heart with simplicity and presence. The other wins your respect with engineering depth and efficiency. And that's what makes this comparison so fascinating, because it's not just about mechanical parts. It's about culture, history, geography, fuel prices, regulations, and the different ways people around the world define what makes an engine great. So when you hear an American V8 rumble to life, you're hearing decades of engineering built around torque, durability, and effortless power. And when you hear a European turbo engine spool up and surge forward, you're hearing decades of innovation built around efficiency, sophistication, and maximum output for minimum displacement. Both approaches created incredible machines. Both changed automotive history. And both still influence the way engines are built today. Understanding that difference helps you understand why some engines feel strong and simple, while others feel sharp and intelligent. It explains why your favorite engine behaves the way it does. And it shows that great engineering doesn't always follow one path. Sometimes the best ideas come from completely opposite directions. If you enjoyed this breakdown and want more deep automotive content like this, make sure to like the video, subscribe to the channel, and turn on notifications so you don't miss the next one. Because here, we don't just talk about cars, we break down the engineering, the philosophy, and the real reasons why machines feel the way they do. And trust me, the next comparison is going to be even more insane.